Hello friends, in last section we understood what is linear regression and what is the use of linear regression, and the last section on the last session, if you are new in this channel, then you can watch my previous sessions where I recorded a session for the linear regression method where we used SDCA is a linear regression trainer, and what is the purpose why we use linear regression. I in depth explained to you in the last section, and just recap what we have learned till now and what you have practices. So we used a data set is called salary data set. For that salary data set, we try to predict the salary based on the experience, and that we did with the help of linear regression trainer, which is offered by ml.net, and the trainer name is SDCA. That is very nice. You learned till now what is linear regression, how you you build your model, how do you train your model, and then evaluate model and save the model into the disk. And in last session, you also learned how we can load the model from the disk. Now, today we are moving in depth session. Today we will talk about what is non-linear regression and why the demand for non-linear regression. Let's try to understand with this example. What is linear regression? So the linear regression means, as you can see in this chart, I prepared diagram for you. In this chart, you can see the experience is a independent variable and the salary is dependent variable, and this is the straight line. So you can see this is the straight line, and let me draw for you. This is our straight line, as you can see over here. So as soon experience is increased, let's say, let me draw at a say different chart. Here this is our slope. As soon as my experience is increased, my salary is dependent on that. This means the number of experience you have, and the proportionate to that your salary would be increased. But this is not solving a real world problem, because the if there is any change in the dependent variable and independent variable, then linear regression will predict the wrong value. I will show you today how the linear regression fail if you have different kind of data set. Let's talk an example. The salary, the way of salary. So salary always not increase in the proportionate. As you can see over here, it is not mandatory that your number of experience, let's say if you are 0 to 5 years, then your salary will increase very fast range. If you are 6 to 8, then your range would be middle. But if your experience is 10 to 15, then speed of salary increment is lower, and if you have 20 plus, then this is slower. Why? Because it is always not possible the salaries proportionately increase based on the experience. There is high increase for the lower experience, and then it becomes stable. So in the linear regression or in the regression, we have one term is called plateaus. You can see over here, plateaus. This means where the proportion are stuck. Yeah, let's say now we have the salary. Take an example. Here is the experience of, suppose, 10 years. Let's say this is our chart, and this is our salary range. Here we have, let me increase for you. Here uh, we, we we have 0, 5, 10, 15. This is our experience, and that's the range of the salary. So the salary will increase very faster if we at range if we range till 5 years, and but after that your experience will increase and your salary will not increase in this proportion. This is called here we stuck. In this area we need another algorithm, or Microsoft.NET ML.NET offered us fast tree base. This means now the constant is not same always, because if you look into this, the regression calculation is pretty simple. The regression calculation, like let's say your salary is equal to constant variable, for example 5000 is a constant, and multiply by years, and that is always not correct, because there are different parameters and there are different factors. So whenever you have the data which use zigzag, or the data having a curve, and this is not best fit for linear regression model. So in the linear regression we can use if slope is constant, because your salaries and the experience, as we talk in this example, is running in a proportionate than your linear, then you can use linear regression. Otherwise you need to change your practice. So the today topic is what is real problem where our linear solution is not giving us accurate value, then we need to change the strategy. So today I'll explain you what is the strategy for tree based search, because only linear regression will not fill or will not solve all the problems. So this is the practical session. You will learn how we change the strategy based on the demand. So today I have different data set for you, which data set have several factors. Let's say the salaries from 0 to 5 increase a faster mode, then 6 to 8 is slower, then as soon as your experience increase, your growth is not as fast as the middle level and the junior level. So let's start working with non-linear solution, and for the non-linear we have different trainers in the ML.NET. So the first trainer I will explain today is FastTree. This means it is pretty clear we are now not dependent only on the straight line where we calculate our predicted values, but now we follow different approach which is called tree based approach. So you can see here in this example there is a zigzag. You can see there are several steps. So the curve is change, step up, step up, step up, step up, it's changing and changing. It's depend. Yeah. Now we use the tree based approach. How tree actually work, what is tree based approach in non-linear calculation or non-linear solution. So the tree based approach always start with a baseline. So the baseline, as we already learned in, or we practice in the last session, the baseline we create with the help of SDCA model, SDCA regression trainer, and this through tree based approach will create a baseline first, then calculate the errors, residual errors. And then what is residual? Do you know? The residual error is residual error. Let me explain to you if you don't know. Residual is equal to actual minus predicted. So the actual minus predicted is called residual error. So it will calculate the residual error and then train a small tree. So when we follow the tree based trainer, when we use the tree based trainer, then it will split our data into multiple small trees, and then the tree learn where prediction went wrong, and the threshold and the plateaus in the data. This is calculate the errors in the small trees, then your prediction would be updated. So update the predictions old predictions plus new learning rate and tree output, and it will calculate one by one tree and then give us the right data. So the tree based approach is utilized, or it can be used when you have the jump in your data. So your data is not stacked forward, so you have some changes in your data, some spikes you seen in the data. In that case, we will use tree based approach. Let me show you one more example here. I prepared for you. Here you can see how this tree fast tree regression model, how it works. So it start at the first stage you can see the baseline which is created. So the baseline, a simple SDCA model, the regression method used for baseline creation. So it's create a baseline, then measure the measuring error, actual minus prediction, actual minus predicted. It continues measuring error. You can see it's in a continuation mode, create finding the errors, and then train small decision trees. So decision trees would be split it and train small trees. Your experience is less than 5 years, less than two, greater than 2 years, less between 5 years and 10 years, between 8 years and 10 years. And based on this approach, the smaller trees would be created. Then it train the small trees and predicting. So the final prediction is, you can see here in this your final prediction is baseline that we have in first record, tree predictions because your data is split into several small trees, then the tree prediction, and first, second, third, how many trees were created, it will accumulate all the trees and then give us the final prediction. This will repeatedly done until errors are not corrected. So this is non-linear regression method. In the next session, I will give you the practical training how we use non-linear regression, how we use FastTree where SDCA was not successfully done or not successfully producing the right output. I will show you what are the matrices, R square, MAE, MSE matrices, those you already know. The evaluation matrices which we tried and we tested in our last session. And today in next session I will present you and I will try to give you the complete knowledge how the SDCA fail and how we can improve our model accuracy using FastTree regression trainer when you have a data. So this is the practical session, guys. Let's follow the next session as well. Thank you very much.